Hello, this is Frederick Janson, and this is the fifth section of my change, value, behavior, and performance theory, which addresses the limitations affecting the valuation of change, specifically using numbers this time. The previous discussions of we and me and the pea in the soup illustrate another flaw associated with the numeric valuation of change. If my first cell, or one cell, is me, and 10 to 90 trillion different cells are also me, represented by some 200 different cell types, how many of me are there? 1, 200 plus, or 10 to 90 trillion? In other words, how can a single whole exist when it is composed of many more than a single whole? It is important to note here that the human body is 10 times more bacterial cells than human cells, and so are we not more bacterial than we are human? It is also important to note that there is evidence that human cells may actually be ancient populations of bacterial cells, as smaller cells within human cells exist, known as organelles, carrying different types of DNA, illustrated by the two different genomes of the nucleus and the mitochondria organelles. And some human cells have more than one nucleus, and all human cells have many more than one mitochondrion, ranging from 1 to 10,000. Accordingly, am I one living thing, or 110 to 990 trillion living things? Or am I all of these things at the same time? It is hard to agree that I am constantly one thing and unique, because I am not constantly one thing and unique, nor is any other thing. So providing numeric valuations to change is very subjective. An example of how numbers are equally flawed and subjective can be illustrated using Benoit Mandelbrot's measurements of the circumference or distance around the United Kingdom. Mandelbrot measured the UK using a standard measuring device, let's say a meter stick, 100 centimeters. Then he remeasured the circumference using a smaller standard measuring device, let's say a smaller ruler with only 10 centimeters. He remarked that the smaller the device, the larger the circumference of the island, as smaller measuring devices could fit into smaller cracks and grooves around the island, measuring more distance. In theory, most things can be cut in half, and so infinitely small measuring devices can be conceived, resulting in infinitely large circumferences of the UK island. Notwithstanding, if the circumference of the UK is measured with an infinitely small device to yield an infinitely large circumference, and these same principles are applied to measure the continent of Australia and the circumference of a small orange, then each infinitely small measuring device would result in the same infinitely large circumference for each of these three different sized objects, though the seemingly larger objects would reach an infinite circumference faster. Which of Mandelbrot's many measurements of the island using different sized measuring devices is the true objective circumference or distance around the island? The answer is either all of the measurements are correct or none of them are correct. If all of the measurements are correct, and they have different values, then no single objective measurement of the circumference exists. If none of the measurements are correct, then no single objective measurement of the circumference exists again. Next, statistics are often employed to infer the numeric probability of large changes by numerically measuring small related changes. However, there is more than one way to perform statistical analysis on a given set of measurements, the results of which can be statistically significant and insignificant for the same set, depending on the statistical design employed to process the measurements. Accordingly, what is the objective probability of a given change occurring when there is more than one way to measure the probability that the change will occur? Another limitation to the use of numbers employs the nature of the constants used in mathematics, physics, and chemistry, and all of the other quantitative sciences, whereby an unchanging value is employed in an equation or measurement used to value changing variables, though that unchanging constant may not actually be constant. A similar constants is the concept of assumptions, whereby the numbers used to value change are based on a set of assumptions, which may or may not be correct. The old expression holds here, garbage in, garbage out, where if the assumptions are significantly incorrect, then the resulting numbers used to value change will also be significantly incorrect. To complicate matters, logic, the precursor to mathematics, employs axioms or fundamental truths to build logic arguments, and if the arguments are not built in a logical manner, so using false or paradoxical assumptions, then the resulting logic and the mathematical or quantitative arguments that ensue will also be garbage. The limits of valuation of change concerned with logic are addressed in a different section. Financial models are derived from quantifiable marketing research. Inaccurate marketing numeric valuation can significantly alter financial numeric valuation. For example, if I ask 10 people who love me if they like my product or service, and find that 90% of the people I ask like and will buy my product, and then I build financial models around these weak assumptions, then the resulting sales of my product across the country will likely not reflect what my financial model expected based on my weak marketing assumptions. Statistical design and analysis can increase the strength of assumptions, but statistical design and analysis are also built on math, logic, and future assumptions based on past trends, which, if inaccurate and misrepresenting, will again result in poor numeric valuation of change.